Welcome everyone to the first video of this chaotic review. In this video we're going to be covering the first three problems, and I've kind of grouped this video or these problems together because if you're going too quickly, these can look very similar, right? So problem number one, find the instantaneous rate of change of a function at a particular instant. Problem number two, find the average rate of change of a function on an interval. And problem number three, find the average value of a function on an interval. And so we really have to remember and be confident about what these terms actually mean. So for problem number one, remember the instantaneous rate of change was another phrase for the derivative, right? Kind of back in chapter one, when we were first starting all of this, we talked about this average rate of change, and then we kind of upgraded to instantaneous rate of change, right? How is a function changing at a particular instant? And that became the slope of the tangent line or the derivative of the function, right? There were a lot of phrases that meant the same thing. So problem number one says, take the derivative and plug in 2. Right? So take the derivative of f and plug in 2. So now that we've kind of decoded, right, what this actually means, actually the problem is relatively easy. Right? So again, f prime of x, well here's my f function up here. This is going to be 2x plus 2. And now we can go ahead and plug in a 2 everywhere we see an x. So that's going to be 4 plus 2, or altogether 6. So again, the answer for problem number one, what is the instantaneous rate of change of our function f at the particular instant, right? When x is equal to 2, the answer is 6. Moving on to problem number two, it asks us to find the average rate of change, right? Before we knew how to take derivatives and calculate out instantaneous rate of change, we were calculating out average rate of change. This is way back in section 1.4, the very first thing that we did. This is the whole f of b minus f of a divided by b minus a. Another phrase that means the same thing, right, was the slope of the secant line, right? We do a similar calculation for slope of the secant line. So okay, let's go ahead and plug in our particular values. We have the endpoint here. B is going to be 4. The initial point is going to be 2, so that's our a value. So we have f of 4 minus f of 2 divided by 4 minus 2. So now we go ahead and we plug these things into our f function. So I'm going to plug in 4 into my f function. So I'm going to have 4 squared, that's going to be 16, plus 2 times 4 is going to be 8, minus 3. And then I'm going to subtract away f of 2. So if I plugged in 2, I would get 4 plus 2 times 2 is 4 minus 3. And so I've purposefully made a mistake here. This is a common mistake, though, that I see, is that, right, I have to subtract away all of f of 2. But how I have it written right here is I'm just subtracting away the 4. So I need to subtract away all of f of 2. So I'm going to subtract away everything. I'm going to use my parentheses here. Alternatively, if you want to just do it in one step, right, you distribute that negative sign, that will also work. But you really have to remember you need to subtract away all of f of 2. All right, let's go ahead and then finish this one out. So 16 plus 8 is going to be 24, minus 3 is going to be 21. And then I'm going to subtract away, okay, 4 plus 4 would be 8, minus 3 would be 5, so I'm subtracting away all of 5, and then I'm dividing by 2. So 21 minus 5 is going to be 16, and you divide that by 2, and we get the answer 8. So the average rate of change on this interval is 8. Okay, finally, problem number 3, find the average value of f on the interval, right? Really the only difference here, instead of rate of change, you have value. And the claim is this is a completely different problem. Right? Problem number 3 here, this was something that we did almost at the very end of the course, right? We found the average value of a function in section 5.5, right? So we need to remember the average value of a function, let's go ahead and write down the definition, is 1 over b minus a times the integral from a to b of f of x dx. So that's the average value of a function here. Now we have a specified interval, 2 to 4, so again my a is going to be 2 and my b is going to be 4. Let's go ahead and start plugging some of that in. So 1 over 4 minus 2 times the integral from 2 to 4 of f of x dx. And in fact, let me, instead of f of x, right, I have a very specific function here. My f function is x squared plus 2x minus 3. So let me go ahead and plug that in. X squared plus 2x minus 3. And we're integrating that with respect to x. So now let's go ahead and compute this. 1 divided by 2, we need to integrate, find the antiderivative here. So I get 1/3 x cubed plus x squared minus 3x. And now I'm going to evaluate from 2 to 4. Now let's plug in 4 everywhere we see an x. So I'm going to get 1/3. 4 cubed is going to be 64. 4 squared is 16. Minus 3 times 4 is going to be 12. And then it's going to subtract away when I plug in 2. So let's see, 2 cubed is going to be 8. Plus 2 squared is going to be 4. Minus 2 times 3 will be 6. Now let's go ahead and simplify a little bit more. So I'm going to have 1/2. I'm going to write this as 64/3 plus 4 minus 1/2, 8/3 minus 2. Now let's go ahead and distribute those halves. So this is going to be 32/3 plus 2 minus, and I'm going to subtract, I'm going to distribute this negative half here. So this is going to be minus 4/3 and plus 1, right? Because there's 2 negative signs here. So all together, let's see, I'm going to have, let me group the thirds together. So 32/3 minus 4/3, that's going to be 28/3. And then 2 plus 1 would be 3. I'm going to go ahead and write 3 as 9/3. So now I can go ahead and combine these here, and I believe I'm going to get 37/3. So that's my final answer here. Remember, 37/3, this is going to be somewhere close to 12. It's a little bit higher than 12. So let's think back to what is the average value of a function, right? What does it actually mean? So we can use our Desmos graphing application, right? Which I've went ahead and I've plotted this for us here. And we're very interested, right, just on the interval from 2 to 4. So of course this quadratic exists kind of everywhere, and so I've done kind of a dashed line here, but we're really only interested on the interval from 2 to 4. So I'm going to go ahead and take it away and just look at the interval from 2 to 4. And we should remember that the average value of a function tells us what is the average height of that function on this interval. So the claim is, maybe if I was to go ahead and graph y equals, and our answer was 37/3, right? 37/3, that's a line right there, that this would be somehow like the average height of this function, this red line, on the interval from 2 to 4. And so yeah, that looks fairly reasonable to me. So I would agree with this answer. One last kind of cool thing we can actually do with this Desmos graphing application is that we can check our work. So if I go in here and I'm going to type in this integral stuff, so I'm going to do 1 divided by 4 minus 2, that's my b minus a, times the integral, so it's going to be I and t, and this makes the integral symbol. So from 2 to 4 of f of x dx, and right, I've already defined my function up here. And notice that it goes ahead and it calculates it for us, right? This says 12.333 repeating, and that's the same thing as 37/3. So this is another kind of good way to verify our work, especially when we have the technology like this. Of course, on a quiz or on an exam and stuff like this, we do have to build up some confidence because we don't get this capability of checking our work, right? So eventually we want to have the confidence and be happy with our answer sort of deal. But here in the review, it's maybe nice to check our work. All right, that's it for the first video. We went over these first 3 problems. I'll see you guys next time.